Welcome back. Also in Chapter 5, we did a lot of factoring. So for these, the first thing that we always want to check for is a greatest common factor. So in number 15, we're going to be able to take out what looks like a 3 from each of our coefficients, as well as, let's see if I go x to the 4th, x to the 3rd, x to the 2nd, I'm going to be able to take 2 x's out of everything. So I'm going to first divide out my GCF of 3x squared. Now, we are not able to just throw it out the window, so we set it gently aside. And we're left with x squared plus 6x plus 9. Now, what's left, that x squared plus 6x plus 9, does technically follow a pattern. It is a perfect square trinomial. If you don't recognize it, that's fine, because we can still factor it like normal. So we can set up our parentheses. We're looking for two numbers that multiply to 9 and add to give me 6. That's 3 and 3. My signs are the same. They are both plus. Now, you can also, or instead, write that x plus 3 times, or as x plus 3 squared, because it's x plus 3 times itself. Now, I don't care which one of those two you have for your final answer. I think the book has this one, and so that's what I included on my answer key. Either would be perfectly acceptable. Number 18, we first need to get 0 on one side. So we're going to move that 48x over, and we've got 3x cubed plus 18x squared minus 48x equals 0. Again, we're looking for a GCF, and again, it looks like we've got a 3 that we can take out of everything, as well as just 1x this time. So from that first term, I get an x squared plus 6x minus 16 equals 0. And then we're going to set up our parentheses. So we've got 3x and then x in both my parentheses. We are looking for numbers that multiply to give me 16 and subtract to give me 6. Numbers that multiply to 16, we've got 1 and 16, 2 and 8. Hey, those subtract to give me 6. So we've got 2 and 8. My signs are different. My bigger number's positive, x plus 8, x minus 2. Now, this time our instructions are different and we are asked to solve. So now we have to take it one step further and set each set of parentheses equal to 0. When I set x minus 2 equal to 0, I add 2 to both sides and I get a positive 2. When I set x plus 8 equal to 0, I subtract 8 from both sides and get a negative 8. Now, since I also had a GCF that included a variable, I automatically have x equals 0 for an additional solution. So my final answers are 0, 2, and negative 8. Number 20, we again need to get 0 on one side. So I'm going to subtract that 3x squared and that 32x, making sure to put it in an order that makes sense. So probably standard form where exponents decrease. So 2x cubed minus that just 3x squared. And then minus that 32x as well, plus 48 equals 0. I would like to take out a GCF, but it doesn't look like I have one this time around. So then I have 4 terms. My best bet, I'm going to start to see if I can factor by grouping. And if that's not successful, I'll go from there. So from my first group, I'm able to take out an x squared. I'm left with a 2x minus 3. And from my second group, I remember to include the sign. I think I can take out a negative 16, and I'm left with 2x minus 3 again, which is good. So I am able to factor by grouping. I take that 2x minus 3 out of both groups. So 2x minus 3 times that x squared minus 16, still equal to 0. I can actually factor further. My x squared minus 16, I have difference of 2 squares. So I have 2x minus 3, and then that becomes x plus 4, x minus 4 equals 0, and then I have to solve. So lastly, I'm going to set each set of parentheses separately equal to 0. From that first set of parentheses, 2x equals 3, x equals, divide both sides by 2, 3 over 2. From the second set of parentheses, I get x equals negative 4, and from the last one, the third set of parentheses, I get x equals positive 4. Of course, whenever we're asked to solve, we can always plug our answers back in. make sure the left-hand side equals the right-hand side. Number 21, I'm asked to divide, and in the instructions they say I can either use synthetic division if possible, or polynomial long division. Thankfully for us, since what we're dividing out is x minus some nice looking number, we are able to divide using synthetic division. So when we use synthetic division, this is when we put our number that we're dividing out in the box, kind of, and then we've got our coefficients. So x minus 3 tells us what we're going to put in the box. We set it equal to 0, and it always just ends up being the opposite sign of what we see. So we're going to have positive 3 in our box for synthetic division. And then also across the top of our box is just our coefficients from our polynomial. Make sure you include any 0 terms. So say I had like 2x to the 5th, and then I went down to x to the 3rd. We would need a 0 for our x to the 4th, because you have to include every single term. So we have our 3 in our box, and then across the top we've got 2, 4, -5, and 16. And to help keep track, if you'd like to put your terms in order, so x cubed, x squared, x and constant, that way you don't forget any 0 terms if you have any. And then we're going to leave a little bit of space, draw on our line, bring down your first term, and then you're going to multiply by the number in the box. 3 times 2, we get 6, and we add, we have 10, and we multiply. 3 times 10, we have 30, we add, we get positive 25. 3 times 25, we are going to get 75, and we add, carry the 1, 91. Remember that that is always your remainder. You always lose 1 degree. So we started with x to the 3rd, which means that our first coefficient is our coefficient of x to the 2nd, plus 10x plus 25, plus, remember that your remainder can always be written as a numerator with what you are dividing by as your denominator. So your final answer, 2x squared plus 10x plus 25 plus 91 over x minus 3.